Hi everyone, welcome to another CISSP session. In this session, we are going to discuss TCB access control, trusted computing base. Before we discuss about this image, how subject can access object, I will explain you how this TCB access control placed in a computer system. The trusted computing base is implemented as part of the operating system security architecture. It consists of hardware, software, and firmware that enforce security policies. The security kernel, uh, shown in the diagram, the security kernel shown in the diagram is the core component of the TCB that controls access between subjects and object, right? So security kernel is a key component which control which controls access between subjects means user and objects means resources. So it does it does that. So it is embedded within the OS kernel such as Windows, Linux or Unix and handles it, right? So mandatory access control for classified data, right? We all know that mandatory access control is for classification, classification of data, right? So we place labels, right, on subject and object. Another control is discretionary protection. It is for administrator defined permission, right? So that is administrator could decide who can access what, right? It is discretionary access control, right? In Windows Active Directory, the TCB is implemented through group policy, user access control, and security audits, right? So in Active Directory, we can define group policy, right? And also user access controls and security audits, all that. In Linux, the TCB includes CLinux, Security Enhanced Linux, which enforces mandatory access control policies, right? So how does the subject object security label work? Both the subject, which could be a user, and object, a resource, user or process, subject could be a user or process, and object could be a resource, right? Have a security label. So, for example, as we know that uh, security, we can classify subject and object with the labels, for instance, secret, confidential, top secret, based on the data, resource, or user criticality, right? So based on that, we can enforce security policy and we can place the labels, right? Access is granted only if security label match, right? As per mandatory access control, if the security label match, then the access is granted. The security kernel checks the security clearance before allowing access. So as we discussed that security kernel is a key component, it checks the security clearance before allowing access between subject and object, right? Let's let's now discuss all these components in this image. For instance, here is user, right? Subject, and it is object, which could be, let's say, in this particular case, um, in this particular example, is HR printer, right? HR printer. It could be anything. It could be a file. Right? So let's assume uh, this user is a Bob, right? And Bob is a subject or user, right? And Bob has secret label. And HR printer object is also labeled secret. So this is also labeled a secret. Since Bob has right, security clearance and access permission as per access control matrix is managed, right? He is allowed to access printer, right? So security kernel will check Bob, the subject which security label this particular user has, and the object, in this case object is HR printer, and and under HR printer we can see print manage, and manage has a secret label. So that means this particular user, which is Bob, can access HR printer only to manage it, right? So this is how access works. And let me now explain step by step breakdown of Bob's access to HR printer. The first thing is authentication. The first thing will authentication. So Bob logs into the system with credential, right? And the system verifies that Bob is a legitimate user. If Bob is legitimate user, then he will be authenticated, right? He will get an access. The second step would be authorization. Now the security kernel checks Bob's security clearance level, right? Now Bob has a secret clearance level. The security classification of HR printer is also secret. Since Bob has secret level clearance, he can request access. The system checks the access control matrix to confirm his manage permission, only manage permissions, right? Because this is an on secret level, right? So first is top secret, this is secret, and the last one is confidential. For instance, Alice has is on top secret level, right? And Cherry is on confidential level. Step 3, access granted and logging accounting. That is also important. Bob is granted access to manage the HR printer. The accounting process logs all action what Bob will perform, right, while accessing this HR printer, right? For instance, modification, whatever it is, those activities will be logged and they can be sent to the logging server, right? That is very important. Authentication, once Bob will logged into the system, Bob credential will be checked whether he's a legitimate user. When he will be when Bob will be a legitimate user, he will get access to the system. Then the next step would be authorization. The system kernel will check Bob's security clearance level, and based on that clearance level, Bob will get an access uh, to the object, right? And then third would be accounting. Accounting is another important component because accounting is for audit, for the logging purpose, the action the action which Bob will perform. So those all will be logged in, right? So now another thing is discretionary protection. It this access control also called DAC. We can also DAC. Um, means administrator can manually assign, revoke access permission for user. It will completely depend on administrators, right? Administrator can provide you the access permission. Uh, Administrator can revoke the access, but this will be done manually. Unlike Mac, where access is mandatory access control, where access is enforced based on security labels, right? DAC allows administrator to override and grant additional permission. This is represented in access control matrix in the diagram where Bob was assigned manage rights to HR printer, right, by an admin. Here you can see, for instance, here discretionary control. So here administrator can provide um, provide printing rights, right, to Alice. So if Bob no longer needs access, then for instance, Alice need no more access, then that access can be revoked, right? It is completely, it will be decided by the administrator. So the final takeaways, TCB is implemented at OS level, Windows, Linux, Unix through security kernels. Access is granted based on security labels and permissions, right? The security kernel enforces authentication, authorization, and accounting. Bob can access the HR printer because both have the secret label and he has been granted manage permission. Administrator can provide override access via dis- discretionary control, allowing Bob if Bob or any other user need any additional permission, right? So this is how this TCP access control works. I hope you have understood. If any feedback or question, kindly share in the feedback section. Thank you so much for watching this video.